Hello viewers, welcome to video number 111 of the channel MALACHEMPHILIC, and this is the 51 episode of Chemical Thermodynamics. Topic of the Chemical Thermodynamics of this video is spontaneity in galvanic cell and application of Gibbs Helmholtz equation. So let's start. Galvanic cell, that means where electricity is generated from the chemical reaction, right? So in galvanic cell, what happened? Galvanic cell, chemical energy is transformed to electrical energy. Okay, electricity is generated from the chemical reaction. Now look at this reaction. Zinc plus sulfuric acid, it is giving zinc sulfate and hydrogen gas. When this reaction is allowed to take place in a beaker, then heat is evolved. Okay, that means it is exothermic. Earlier it was believed that this heat evolved during this reaction is equivalent to the electricity produced or electrical energy produced when this reaction is allowed to take place in the galvanic cell. This was believed earlier. When this reaction is allowed to take place in the galvanic cell, that heat evolved during this reaction is equivalent to the electrical energy produced. But according to Gibbs Helmholtz, this is the free energy change that is responsible for the electrical energy produced in the cell. So, according to Gibbs Helmholtz, what is that? According to Gibbs Helmholtz, the electrical energy produced in the cell, the electrical energy produced is at the expense of free energy change. Right? Now, this electrical work done, or electrical energy produced, whatever it is, this electrical work done in the galvanic cell, that is equal to the charge into potential difference. Potential difference means potential difference of the two electrodes in a galvanic cell, which is known as the EMF or electromotive force. Right? Now, this electrical charge, that will be is equal to N into F. Now, what is N? N is the number of electron transfer. See, in the galvanic cell, this electron transfer reaction occurs, At anode, oxidation takes place, that means electron is released there, and at cathode, reduction takes place where electron is accepted. That means electron transfer reaction occurs, right? Now, this N indicates the number of electron transferred, number of electron transferred in the cell during the electron transfer reaction of the cell, right? And F is this is Faraday. Faraday means which is 96500 coulomb of charge, and that is the charge of 1 mole of electron. This is the charge of 1 mole of electron. That is your Faraday. So, number of electron transfer, or in terms of moles, number of moles of electron transfer into this Faraday, that is the total charge. Therefore, electrical energy produced. So, here electrical energy produced that will be is equal to NF, charge into EMF or potential difference, that is E cell. Okay, and already I have told you that according to Gibbs Helmholtz, this electrical energy produced is at the expense of free energy change or decrease in free energy. Therefore, this minus delta G, decrease in free energy, that is equal to NFE, or this change in free energy is equal to minus NFE, right? E is the EMF or electromotive force. You can write E cell also. Right. Now from here, from this equation, you see when EMF of the cell is positive, then only free energy change will be negative, then the cell operates spontaneously. So, when E cell is positive, E cell is positive, EMF is positive, that means then delta G will be negative. And under this condition, then the cell operates spontaneously. So, what is the condition for the cell, galvanic cell, to operate spontaneously? That is, EMF of the cell must be positive, so that free energy change will be negative, because electrical work done or electricity generated in the cell at the expense of decrease in free energy or change in free energy. Right? So, this is the condition. Now, let's come to this application of Gibbs Helmholtz equation. Application of Gibbs Helmholtz equation. Okay, this part also, where we have proved that it is the free energy change that is equivalent to electrical energy produced, that also has come from this Gibbs Helmholtz equation. So, application of Gibbs Helmholtz equation, we know already in video number 109, I explained Gibbs Helmholtz equation. I have derived all the forms of Gibbs Helmholtz equation. You can refer to that. Link is given in the description box. So, what is Gibbs Helmholtz equation? Gibbs Helmholtz equation delta G is equal to delta H plus T dole of delta G by dole T at constant pressure. Okay. Now we know that this delta G is equal to minus NFE in the galvanic cell. So, it is minus NFE is equal to delta H plus T, then dole of minus NFE by dole T at constant pressure, right? Now, this one I can write it as E is equal to minus delta H by NF, and then here it is T, because NF and by NF will get cancelled and minus minus plus. So, this will be dole E by dole T at constant pressure. Right. Now this one, this term dole E by dole T at constant pressure, this is known as the temperature coefficient of EMF of the cell, which is the potential difference of the two electrode in the galvanic cell. So what we found, that E cell or EMF, this is E cell or EMF, is equal to minus delta H by NF plus dole E by dole T at constant pressure. And this term is the temperature coefficient of EMF. Now, from this equation you see, when dole E by dole T at constant pressure, that means temperature coefficient of EMF is equal to 0. In that case, when this temperature coefficient is 0, then your E cell, that means that electricity or electrical work done, or that means the electrical work done is equal to your change in the, or decrease in the enthalpy or heat evolved in the reaction, cell reaction, right? Otherwise, EMF is equal to, that means the electrical energy produced is equal to the decrease in the free energy, right? And now from this equation, that means which derived from this Gibbs Helmholtz equation, look at here, see, from here, if you know this temperature coefficient of EMF and if you know this E cell or EMF, then you can calculate the heat evolved, that is change in the enthalpy. So from equation 1, say this is equation 1. So from equation 1, what do we know? If dole E by dole T P is known and EMF is known, then delta H can be calculated and vice versa. That means if this temperature coefficient is known and if this heat evolved, that means change in enthalpy is known, then EMF of the cell can be calculated. Okay, these are the applications of Gibbs Helmholtz equation. Now let's solve one problem. Then it will be clear. See, the problem is, can the following cell at 298 Kelvin operate spontaneously? The cell is left hand side. In the galvanic cell, left hand side is anode where oxidation takes place, sign is positive. Right hand side is cathode where reduction takes place, sign is negative. Okay, and here left hand side reaction is zinc is oxidized to zinc plus 2. Right hand side reduction reaction is lead plus 2 is reduced to lead. Right? So, what is the cell reaction? Here overall cell reaction is zinc minus 2 electron. It is giving zinc plus 2 and lead plus 2 will take 2 electrons and it is giving lead. So, the overall reaction is zinc plus lead plus 2, that is zinc plus 2 plus lead. This is the overall cell reaction. Right? Now, this EMF of the cell or E cell is the potential difference between these two electrodes in the galvanic cell. And here it is given reduction potential. Okay, zinc plus 2 reduction to zinc. Lead plus 2 reduced to lead. Reduction potential value is given. E cell or EMF is equal to reduction potential of cathode, reduction potential of cathode minus reduction potential of anode. Okay. That means you write it as ER. R means right hand side. Right hand side is cathode minus EL. Left hand side is anode. So, what will be the EMF of this cell now? That is E cell is equal to E cathode minus E anode. E cathode is equal to, they have given the value, cathode value is minus 0.126 volt. So, it is minus 0.126 minus of anode reduction potential is minus 0.762 volt. So, minus 0.762. So, here it is minus 0.126 plus 0.762. How much it is coming? 62, that is 6, and then 3, that means 3, and then 6, that means 0.636 volt, and it is positive. That means it is plus 0.636 volt. Okay. So, E cell or EMF is positive. Since E cell is positive, then delta G must be negative. So, the cell operates spontaneously. Okay. So, what we have observed that in the galvanic cell, the condition or criteria of spontaneity, whether the cell will operate spontaneously or not, that is EMF of the cell must be positive. Hope you have understood. Thank you.